How to configure the M340 to control an ATV32 over Ethernet. First, the hardware. You need an ATV32 and an Ethernet module that supports Modbus TCP or Ethernet IP. On the M340, a rack-based 4-port managed switch that supports both SIP and Modbus over Ethernet. We can also use the Modbus TCP module for M340, but that's a video for a different day. I would recommend that you watch the video entitled Control an ATV32 Ethernet from a Unity PLC, Drive Configuration Parameters. This video goes into great detail on the drive configuration parameters, but let's review them now for this application. I'm going to open SoMove Lite. We've got the channel mode configuration set for separate. The command word is going to be based on a 12th bit of the control word, and if that bit is 0, we're going to use the COM card. If not, we'll use the terminals. The reference switching will be based on that 13th bit. We're going to control the reference speed via the COM card or via the HMI on the ATV32. We're using Modbus TCP, and our IP address is 192.168.10.30. Modbus TCP settings, we are enabling the I/O scanner. We're using the default addresses, and the master IP address is 192.168.10.11 with a 5-second Ethernet timeout. The drive will fault out if the comms if it loses comms for 5 seconds or more. When the drive does fault out, it will stop. So let's configure the M340. I have a new program here. I'm going to add an NOC module. Again, NOC stands for Network Option SIP Protocol. And when I double-click the module, we'll go in and configure the memory that it's going to take for Ethernet IP or Modbus TCP. So we're going to use 18 registers, 2 additional inputs for the ATV32, and 2 additional outputs. That will be for the control word, the reference speed, the status bits, and the running speed. And we'll accept those modifications. We're going to open the DTM Browser from the Tools menu. DTM stands for Device Type Manager and provides a unified structure for accessing device parameters, configuring, operating, and diagnosing devices. You can get more information on DTMs from fdtgroup.org. If you don't have an option to add the NOC module, download the user manual for that module from our website. Instructions for installing the DTM are in that manual. So now we'll double-click the module. And first step is I am going to set the IP address of the module. So the IP address, if you recall, is 192.168.10.11. Change the channel properties. The source address is going to be the IP address of my computer, which is 192.168.10.99, and then we're going to search under Modbus, because we are using the Modbus TCP portion, and I'll just search from 20 to 40. The IP address of the drive is 30, but we can do a search. So I'm going to apply those changes. The next step is I'll connect. Right-click on the NOC module and connect. right click again on the NOC and we'll do a field bus discovery. So it's going to go out and look for all the devices between 20 and 40 on our IP and discover that I have an exact match of an ATV32. So I'm going to double click it so that I've selected that, and I'll OK this. At this point I like to rebuild all the project. I will right click the ATV32 and I will load the data from the device itself. Alt F. We'll load all the parameters from the drive. Again, I like to rebuild changes, rebuild often. I'll open the device list. I'm going to disconnect. Disconnect from the NOC module. And I'm going to re-import the items just to be sure we've got everything in there. Re-import. Apply. Apply. And again, rebuild the entire project. So what I'll do now is I will connect to the PLC. We'll transfer the project to the PLC. I'm equal, running, the project is built, and I'm connected. So what I'm going to do now is open the project browser, and I'm going to build a quick animation table. And I will select our two ATV32 channels. Shift, hold, OK. I'm going to close the DTM and close the project browser. I'm going to give the drive a running speed or a commanded speed. Got to modify. So we'll give it a speed of 900 RPM. I will energize the drive, I will enable the drive, and I will run the drive. And we can see the drive getting up to 900 RPM, which is 30 Hertz. If I change the speed to 1800 RPM, and I can also monitor, I'm going to minimize the animation table. And I will bring the website of the drive up so we can see it running. Right now it's running at 60 Hertz. So if I pull my Unity program up, I can change the speed again to 30 Hertz or 900 RPM. The drive is running. Let's make this smaller. And I can tell the drive to stop.